is Josie,
My name is Baker.
and today we will be showing you all about fission and fusion and why it's important.
Today we're going to describe what happens during both processes and how energy is created.
And don't forget to like, comment, and subscribe.
Okay, fission, fusion, and why they are important. This is fission. Neutron hits nucleus, creates five things. 3 neutrons, 2 fission products. Fission is really interesting. Okay, this third definition right here, this is the one we care about. It's the splitting of an atomic nucleus resulting in the release of large amounts of energy. Well, it's also how unstable atoms become stable, specifically uranium-235. Uranium-235 gets slammed into by a stray neutron to become uranium-236, which is highly, highly unstable. Like, it doesn't want to be uranium-236 at all. So it instantaneously splits apart, creating 2 new atoms, both of which are way more stable than the original one. So those 2 stable atoms get slammed into by other stray neutrons because this just starts a whole big chain reaction that everybody wants to get in on. And see here, you can see the release of energy caused by the splitting of the nucleus to fire off 3 brand new incident neutrons. So why is fission important? Fission is important for several reasons. First, it's how nuclear reactors produce energy. It's how power plants that run on nuclear power or are able to produce energy and are able to provide light and heat and electricity for our homes and for the electricity that is allowing for the production of this video. I mean, come on, it's a great thing. It's also really important to the economy because it's a big business. You have the extraction of uranium, which has to be dealt with very, very carefully. You have the process itself, so you have to have people who can monitor the reaction and who actually know what they're doing as to not blow it up. And then you also have the disposal of radioactive waste. It has radioactive waste, especially that produced during the reaction with uranium-235 has to be disposed of in certain ways. And so there are lots of jobs because of that. And specifically here in Georgia, we have Plant Hatch and Plant Vogtle. I think that's how you say that. Both of them are nuclear power plants here in the state, and they provide a lot of jobs to the economy. In fact, it's one of the top sources of jobs. And plants get their energy through a variation on the fission process. And then it's also very dangerous because do we really want to repeat of Chernobyl? Yeah, so the extra mass produced releases energy according to Einstein's equation. I'll talk more about it with fusion though. It's more important. So, fusion. Fusion is the opposite of fission. You have deuterium and tritium colliding together to create helium and 1 stray neutron, and that releases energy. And you need extremely high pressure and millions of degrees Celsius in heat for the reaction to occur. So you're probably wondering, where does this reaction occur? Perhaps? Well, it's a nuclear process where energy is produced by smashing together light atoms. Light is a key word here. It's the opposite of fission, where heavy isotopes are split apart. It's the process by which the sun and other stars generate light and heat. So it's essentially the reason why us and everything here on Earth is alive. So it's typically done with 2 hydrogen isotopes, deuterium and tritium. And you create an alpha particle and a neutron, and then extra mass is formed in the reaction as well. Because you have your helium and then you have your neutron. And then all the extra mass that is produced by the reaction is released as kinetic energy into the surrounding environment according to E equals mc squared. And fun fact, it doesn't occur naturally on Earth. So we can't use it to power plants because it would be so much cheaper. But there are reasons. It's important for several reasons, though, because yes, it could potentially solve the world's energy crisis, but It's very, very, very expensive to do, and there are only a handful of places on Earth where the reaction can occur safely and in a controlled environment. Simply put, the cost of fusion would outweigh the profit. And it's how the sun warms the Earth, it's how the sun emits the energy, the light and the heat energy, that make Earth a livable environment. And cell fusion, unicellular organisms become multicellular through fusion. And here's the sun providing us all the warmth and light it could possibly give. So, for a final recap, we have fission, the splitting of atoms into smaller atoms to provide energy. It's possible on Earth, yet super dangerous. And then we have fusion, which is the opposite of fission, but it isn't possible on Earth and has half the risk. Which one would you choose?